Selecting shade for patient. What do you consider? Value, chroma, and hue. What is the first thing you consider of these three? Number one, hue. Number two, chroma. Number three, value. First, so to know about value, chroma, and hue, we need to first know about metamerism. Metamerism is a phenomenon that causes teeth and porcelain to appear color matched under one light source but appear very different under another light source. It appears different under different lights. This property is important in matching the shade of a porcelain fused to metal crown to a natural tooth. Thus, if possible, color matching should be done under two or more different light sources, one of which should be sunlight. Staining a porcelain restoration decreases value and increases metameric responses. Again, staining a porcelain restoration decreases value and increases metameric responses. The light source affects the perception of the color because the light source must contain the wavelength of the color. To be matched in order to see that color. Again, light source affects the perception of color because the light source must contain the wavelength of the color to be matched in order to see that color. Now, fluorescence, an optical property by which a material, in this case teeth, reflects UV radiation. The energy the tooth absorbs is converted into light with longer wavelengths, in which the tooth actually becomes a light source. Human teeth fluoresce mainly blue-white hues of 400 to 450 nanometers. Okay, blue-white hues. Human teeth fluoresce mainly blue-white hues of 400 to 450 nanometers. Fluorescence makes a definite contribution to the brightness and vital appearance of natural teeth. Blue fatigue accelerates yellow sensitivity. This means if you look at blue color objects, for example, drapes, charts, wall color, while selecting the shade, it helps accentuate the ability to discriminate yellow shades. Blue fatigue. So blue fatigue accelerates yellow sensitivity. This means if you look at blue color objects like drapes, charts, wall color, while selecting the shade, it helps accentuate the ability to discriminate yellow shades. The production of color sensation with a pigment is a physically different phenomenon from that obtained by optical reflection, refraction, and dispersion. The color of a pigment is determined by the selective absorption and selective radiation, or scattering. The shade of a ceramic crown is matched first based on the color's value, chroma, then hue. So first value, then chroma, and then hue. Value, then chroma, then hue. Again, shade of a ceramic crown is matched first on the color's value, chroma, then hue. Okay, so value, then chroma, then hue. Value a color's brightness, the most critical characteristic that is matched first. Value is the relative amount of lightness or darkness in a color, the intensity of a color. An elevation of value represents the most important aspect in shade selection for the restoration to match an existing dentition. In aesthetics, the value of a denture tooth depends on the relative whiteness or blackness of its color. Staining a porcelain restoration or using complementary color will reduce the value. It is almost impossible to increase the value. A 60-year-old patient compared to a 25-year-old patient is most likely to have teeth with a color that is lower in value and higher in chroma. Why? Because chroma is a color strength or saturation, the aspect of color that indicates the degree of saturation of the hue. Again, the aspect of color that indicates the degree of saturation of the hue, that is chroma. Chroma is the single most important factor in shade matching. Chroma can be successfully increased by using stain, especially in the gingival area. Now, hue is the basic color. The color families like red, blue, yellow, green, etc. Drastic changes of hue, color, or shade are often impossible. Orange stain is most often used to change the hue. So, the most important one is value, then chroma, then the hue. Okay, so next question. The cantilever abutment has the worst prognosis. K9 as abutment for cantilever. K9 as abutment for cantilever. Next question. After perio surgery, most important thing for success? The answer is no retained plaque. Keep plaque-free environment. After perio surgery, the most important thing for success is no retained plaque. Keep a plaque-free environment. After perio surgery, how does a patient clean interproximal surfaces? Soft brush, warm water, chlorhexidine at 0.12% 2 times a day. 2 times a day. Okay. In crevicular fluid, what cells do you find? Let's see crevicular fluid. Let's study that. Crevicular fluid. Crevicular fluid. Let's see. In health, the gingival crevicular fluid is a transudate that emerges from the gingival sulcus. The gingival crevicular fluid may contain a variety of enzymes and cells, particularly desquamating epithelium and neutrophils being shed through the sulcus. Okay? So, may contain a variety of enzymes and cells, which are desquamating epithelium and neutrophils being shed through the sulcus. An increase in gingival crevicular fluid flow is the first detectable sign of an inflammation. Once inflammation has occurred, the gingival crevicular fluid is called inflammatory exudate, which contains a higher level of serum proteins and leukocytes. Nutrient materials for the gingival epithelium cells are supplied mainly from capillaries and subjacent connective tissue. Okay, so what cells do you find in the crevicular fluid? You will find, according to the Bourbusters, you will find desquamating epithelium and neutrophils. What else? Let's go to dental secrets. Dental secrets will have the question in dental secrets is, what is gingival crevicular fluid? Is an ultrafiltrate of serum, therefore contains many of the components of serum, particularly complement and antibody. Flow rates of crevicular fluid have been used in attempt to predict disease activity. Furthermore, investigations have been interested in gingival crevicular fluid for other markers of periodontal breakdown, e.g., beta-glucuronidase, interleukin, and collagenase. Next, the dentin NBD Part 2 about crevicular fluid says gingival crevicular fluid in health is a transudate that emerges from the gingival sulcus, may contain a variety of enzymes and cells, particularly desquamating epithelium and neutrophils being shed through the sulcus. An increment in GCF flow is the first detectable sign of inflammation. Once inflammation has occurred, gingival crevicular fluid is called inflammatory exudate, which contains a higher level of serum proteins and leukocytes. Another thing about crevicular fluid is let me see. In perio, we can see about crevicular fluid. we can see that gingival clavicular fluid. Let's see. Okay, what is the main type of cell in gingival clavicular fluid in gingivitis and periodontitis? Well, in clavicular fluid in on gingivitis and periodontitis, you have polymorphonuclear nuclears, lymphocytes, neutrophils, or plasma cells. And the answer seems to be polymorphonuclears. On gingivitis, there is 4 stages. In the first stage, we'll find polymorphonuclears in the initial stage. Then on early stage, lymphocytes. Then established state, plasma stage. And then in the fourth one, advanced periodontitis, we'll see it's a plasma stage. So the answer seems to be polymorphonuclears. Polymorphonuclears, neutrophils. Polymorphonuclears, neutrophils. Polymorphonuclears, neutrophils. Clavicular cell fluid. What cell do you find most? Polymorphonuclears, neutrophils. Next question. After removing plaque of 2 days, what bacteria do you find? The answer says Fusobacterium nucleatum, Prevotella intermedia, and Capnocytophaga species. By a week time, tertiary colonizers and include Porphyromonas gingivalis, Campylobacter rectus, Echinella corrodens, Actinobacillus actinomycetin comitans, and the oral spirochetes like Treponema species, Initius species, Spirochete sanguis, Actinobacillus viscus, and Streptococcus mutans. The C factor. C factor, the ratio of bonded to unbonded surfaces of a composite restoration. Polymerization shrinkage in a composite creates stress that can damage surrounding enamel walls of the cavity preparation. The amount of stress depends on the C factor of the composite restoration. A high C factor indicates the cavity is more likely to be damaged. Incremental curing reduces the C factor and therefore reduces the residual stress of the resulting composite restoration. So decreasing the C factor is done by incremental curing, and these will reduce the stress resulting of the resulting composite restoration. So The C factor is related to the cavity preparation geometry and is represented by the ratio of bonded to non-bonded surfaces. Residual polymerization stress increases directly with this ratio. The worst C factor is CL1. Rating grade 5 bilateral split osteotomy. Okay, no. That's another question. So C factor is related to the cavity preparation geometry and is represented by the ratio of bonded to non-bonded surface areas. So, another question is it best to have 4 or 1 C factor? It is best to have C factor of 1. The higher the C factor, the more will the detrimental effects of polymerization shrinkage. Okay. So the C factor, that was the C factor. Let's go to Dental Secrets to see more about C factor. C factor, let's see. So the C factor is ratio of bonded to unbonded surface areas of a composite restoration. The polymerization shrinkage in a composite creates stress that can damage surrounding walls. The amount of stress depends on the C factor of the composite restoration. A high C factor indicates the cavity is more likely to be damaged. Incremental curing reduces C factor and therefore reduces the residual stress of the resulting composite restoration. Okay, let me see if I find another explanation of C factor. Okay, well, so there's an explanation. The C factor is a configuration factor or ratio between the bonded surface area of a resin-based composite restoration to the unbonded or free surface area. The higher the C factor, more will the detrimental effects of polymerization shrinkage. So, for example, you have this 1, 2, 3, 4, 5 occlusal class 1 preparation. Okay, C factor of 5. But why? Because you have 1, 2, 3, 4, 5. The proximal five walls that need to be polymerized. Proximal occlusal class 2 preparation, C factor 4. 1, 2, 3, 4. Mesio-occlusal class 2 preparation. Well, anyway, the lowest the C factor, the better. I don't understand exactly why, but I'm gonna have to Google that and see exactly why. So the cavity configuration, or C factor, is defined as the ratio of the bonded to the unbonded surface area. To investigate the effects of cavity C factor and LED curing mode on microleakage of class 5 resin composite restorations. Anyway, there's a lot of information, but here it is. For a class 1 preparation, there would be 5 bonded surfaces and only 1 unbonded surfaces. The net result would be a C factor of 5, with an increasing C factor that developing curing contraction stresses of bonded restorations increases too. Again, with an increase in C factor, the developing curing contraction stresses of a bonded restoration increases too. The developing curing contraction in a bonded restoration generates stress on the bonded interface that are in competition with the developing bond strength of the setting restorative to the cavity surfaces, which may result in debonding, partial leakage, and postoperative pain. Internal stress can be reduced in a restoration subject to potentially reduce high disruptive contraction forces by using soft start polymerization instead of high density light curing. Incremental layering to reduce the effects of polymerization, shrinkage, and stress breaking liners such as a field adhesive, flowable composite, or resin modified glass ionomers in application of non or low shrinkage restorative materials. So, there's an image. Here you'll have 1, 2, 3, 4, 5 surfaces. Here you have I don't know why, but 2, I guess. And here you have 1. You also have 1 here and 2 here. So the lower the C factor, the better. Next question. Which tissue is least radiosensitive? Neurons, skeletal muscle. Cells that are mitotically active are the most radiosensitive, like basal cells of the oral mucosa. Skeletal muscles are least radiosensitive. And in the board busters, we're gonna see that study about radiation injury. Sequence of radiation injury. Latent period is a period of time between radiation exposure and onset of symptoms. It may be short or long, depending on the total dose of radiation received and amount of time it took to receive the dose. The period of cell injury comes after the latent period. Cellular injury may cause cell death, changes in cell function, or abnormal mitosis of cells. Third is the recovery period, the last event in the sequence of radiation injury. Some cells recover from the radiation injury, especially if the radiation is low level. Now, effects of radiation. Again, effects of radiation exposure are additive, and the damage that remains non-repaired accumulates in tissues. The cumulative effects of repeated radiation exposure can lead to various serious health problems, like carcinogenesis, which leads to various carcinomas, genetic mutations that increase birth defects, different leukemias, and cataracts. Carcinogenesis and genetic mutations are important and serious effects of repeated exposure to low doses of radiation. Again, carcinogenesis and genetic mutations are important and serious effects of repeated exposure to low doses of X radiation. The mechanisms involved are due to frame shift mutations, synergism with chemical carcinogens, and altered DNA repair enzyme functions. Cells in the body have different sensitivities to radiation. In general, the greater the rate of potential for mitosis, and the more immature the cells and tissues are, the more susceptible or sensitive these cells are to radiation. Radiosensitive cells are small lymphocytes, which are immature blood cells, bone marrow, reproductive cells like sperm and ova, and immature bone cells. Prostate gland is very sensitive to radiation. Hemopoietic tissues is the most sensitive to radiation. Radio-resistant cells are going to be mature bone, muscle, and nerve. Mature bone, muscle, and nerve. Muscle cells are the most radio-resistant. Now, the radiation absorbed dose is the RAD, a measure of energy imparted by any type of ionizing radiation to a mass of any type of matter. The radiation unit of absorbed dose is the rad. Now, equivalent dose, which is the dose equivalent, the correct unit of measurement used by the dentist to compare the biologic risk effects estimates of different types of radiation damage to a tissue or organ. That's the equivalent dose. That's the correct unit of measurement used to compare the biologic risk and the effect or estimates of different types of radiation damage to a tissue or organ. The effective dose is used to estimate the risk in humans. Rontgen is the traditional unit for radiation exposure measured in air, and it only applies to X-rays and gamma rays, and is a measure of radiation quantity, capacity of the radiation to ionize air. X-rays have more energy than light. About 1% of the energy released in the X-ray tube is released as X-rays. Electromagnetic radiations includes microwaves, X-radiation, visible lights, and gamma radiation. X-rays and gamma rays are types of non-particulate radiation energy. So, skeletal muscles are the least radiosensitive. Clavulanic acid on augmentin, which is amoxicillin with clavulanic acid, 875 milligrams. Increase the action of penicillin because clavulanic acid is a beta-lactamase inhibitor, and it's good for treatment of Haemophilus influenza, Neisseria gonorrhea, E. coli, and pneumococcal. Okay, we're gonna stop there.